So hi everyone, this is the task presentation for the task 6.3 HD, which is the awesome tutorial on the quick protocol. So let's start. First we will understand that why are we using the quick protocol. So the limitation with existing HTTP2 plus TCP plus TLS2. So first of all, we will see that what is the limitation with the existing protocol. So the existing protocol requires multiple round time trips before sending the data. Head of line blocking is there. That means that one lost packet can block everything. TCP and TLS are separate, which causes extra delay. Latency causes a major bottleneck. TCP handshake plus TLS handshake adds delay. So the quick was designed to reduce latency, improve reliability in the transport layer. So basically the quick protocol was made by Google, and the quick protocol was made on top of the UDP as UDP protocol as its base. So the quick protocol uh, cannot be developed like we use TCP. As the TCP is developed in the OS kernel, we cannot just develop the quick protocol just like we developed TCP, because since the 1980s the TCP is built inside the OS kernel, and to introduce a new protocol with significant changes like we did in quick, we need to change the some settings from our operating system, which will take a lot of time, which can take years. So doing this could be a bad idea. Also, the middleware devices like the routers, they understand the protocols like TCP and UDP. They do not recognize any new protocol, so the firewall of routers may block the quick packets from moving if we introduce a new protocol. So this is the reason why the quick protocol is built on the top of UDP. Next is the quick architecture. Here we can see in the application layer we have some user application like browser, video streaming applications. So these uses the HTTP version 3, which runs on the top of quick instead of TCP. And in the next we have the quick layer. So this is the core layer that manages the communication using UDP and the built-in features of the UDP. It handles the multiplexing, the encryption, the reliability, and the connection control. Here we also have a connection migration, means the connection will be kept alive even if our data is changed. So we use connection IDs in the quick layer. Um, the connection ID is basically used for identifying the connection. So even if the IP addresses changes, if the connection fluctuates and the IP address changes, still we will be connected to the website through the connection ID, though the connection ID will not change. We have the TLS 1.3 security. We have the feature of multiplexing as the multiple streams work together. There is a dedicated stream for each web object, which manages the head of line blocking as seen in TCP. We have the stream management in the quick layer. Let's move to the next slide. So this is the comparison between the HTTP version versus quick plus HTTP 3. So we can see the features. So first of all, for HTTP 1.0, HTTP 1.0 is the persistent connection protocol. We have a non-persistent protocol. TCP uses that protocol. Connection type is new connection per request. So we have to create TCP connection again and again for every web object we request, for every HTTP request we send to the server. So there is no multiplexing, no head of line blocking, no encryption, handshake time and packet loss impact is really high. So the data transfer rate is very slow. But in 1.1 we had some significant changes, like we had a persistent connection, but still there was head of line blocking, still the handshake time was high, still the packet loss impact is really high. So then we can see our HTTP 2 version. So in the HTTP 2 version, the connection type is a single connection type. Multiplexing is there, head of line blocking exists, HTTPS encryption is there, the handshake time is really high, packet loss impact is also really high. Here we can see the quick plus HTTP 3 protocol. So this is basically built on UDP, single connection, Multiplexing, yes. Head of line blocking is removed here. Encryption is built in. So the handshake time is very low, as we can see. 1 RTT or 0 RTT. So 1 RTT is so first of all, if I want to I want to log into Amazon.com, so I will directly log into Amazon.com. For the first time, if I log in, then 1 RTT will be used. But the next time I will use it, next time I open the Amazon.com during a specific duration, then what will be happen? The session ticket will be stored inside the browser cache, and inside the session ticket we have a PSK, pre-shared key. So that pre-shared key will be used to establish the connection without even any RTT used. So this is the significant changes that the Quick introduces. Also, we have no packet loss impact. Sorry, we have no packet loss impact, very low packet loss impact, as we have independent streams, so there will be no packet loss impact. As in the TCP, what will happen if a packet is lost, then the other packets will be stored in the TCP buffer and will not be sent to the application until all the packets arrive. So there two protocols are used, sliding window and go back end. So there is nothing like that in Quick. So that is a major advantage of Quick protocol. Here it shows the communication diagrams like in HTTP2. We have this 1 RTT, this 2 RTT, 3 RTT before even we can send a single packet of data. So this causes a major delay. For HTTP 3 plus Quick, so there is no major delay. We just have 1 RTT, or we can also have 0 RTT, as I explained earlier. So now let's see why the Quick uses the UDP protocol. So the UDP protocol is very simple and fast. It has no connection setup, no three-way handshake. So our data can start flowing immediately with less delay. Whereas we can see that the Quick protocol uses the UDP as its base, and it builds its own features on top, like reliability for retransmissions, congestion control is there, uh, encryption is also there. So the Quick protocol runs in user space, so not inside the OS like TCP. So there is a significant advantage for the developers, as they can improve it faster without waiting for the changes in the operating system. So the Quick uses UDP as a lightweight base, and it re-implements the TCP features like reliability, congestion control in user space for better speed, flexibility, and control. Here is the results comparison that I took from a research paper. So this image is from a research paper. I have cited it. We can see in the figure we have the Quick versus TCP when downloading a 210 MB object. So the bandwidth fluctuates between 50 and 150 Mbps. So it randomly picks a rate in which the range every second. So Quick is able to achieve average throughput of 79 Mbps, whereas TCP only has an average throughput of 46 Mbps. So that is a significant amount. So this graph compares the Quick versus TCP throughput while downloading a file. Here the internet speed keeps changing between 50 to 150, like in the real world condition. The blue line Quick is mostly higher, meaning the download speed will be faster. The purple line TCP is lower and more stabler, but it is slower overall. So here the Quick reaches around 79 Mbps on average, while TCP only reaches 46 Mbps. So I also wanted to show the Wireshark analysis of Quick. So to understand how Quick works in real network communication, the Wireshark was used to capture and analyze the packets. So the objectives were to how the Quick protocol operates over the UDP, how the packets appear during transmission. So here we can see that during capturing the Quick traffic, we can see that all the Quick packets are here. So we just applied the filter of UDP here. So we can see there are Quick packets also. So it uses UDP protocol. You can say that using this. So the quick uses a UDP instead of TCP. Here we don't have any type of, we can see no SYNAC or ACK quick TCP handshake. The payload is encrypted. That means it uses any version like the TCE, like the TLS 1.3. So the payload is encrypted. Like in TCP, we can clearly see what text is being sent, like the full request URL. This text is being sent, but in the quick, everything is encrypted. The payload is completely encrypted, so it will be encrypted using the session key or the pre-shared key. Here we can see the multiplexing of stream, though we are not able to identify that these are being multiplexed, but we can just get an idea that these are the multiplexed streams. So here we can see the connection behavior. So we can see this. Yes, here we have the connection ID, source connection ID and destination connection ID. So it means that it runs on the connection ID, not on any source or destination IP. So this was the Wireshark analysis and the complete presentation. Thank you so much.